So 3-7. We're going to be doing inequalities. Inequalities. Okay, so we'll get through most of this today. So tomorrow we'll finish it up and then spend a little time going over what's on your test on Tuesday. So this is polynomial and rational functions, but we're doing inequalities. So what we want to talk about is that these concepts are synonymous. So when we're solving and we want to solve f of x is greater than 0, yes, the outputs are positive, but what we're really going to be looking at is that the graph is above the x-axis. And then vice versa. If it's less than 0, it'll be below the x-axis. Okay, so first of all, we're going to look at quadratic inequalities. So quadratic and polynomial inequalities, what we want to do is find the zeros. Okay, so we'll start off by finding the zeros. So I want to know when x squared minus 5x equals 0. So when it's quadratic, we like to factor, if possible. If not, we can use quadratic formula. I can factor this one. How would I factor it? Yep, factor out an x. So that's x minus 5. Okay, so then my zeros are x equals 0 and 5. Okay, so let's think about that now on a number line. So my number line is going to be like my x-axis, because I'm going to sketch this graph, but just with the x-axis. So I have 0 and 5. Okay, my inequality is less than 0. So would that be open or closed circles at 0 and 5? I hear it, but say it louder. Okay. 0 and 5, open circles. All right. This is a quadratic, so what's the graph of a quadratic? Yeah, it's a parabola. And the a value is 1, so does this parabola open up or down? Up. All right, so it looks like this. Something like that. Okay. So I want the part that's less than 0, so I want below the x-axis. So the part that's below is right here. When you solve inequalities, you write your solutions in interval notation. So on the number line, this is the part that's shaded. So the part that's below is between 0 and 5. And I have open circles there. So when I write my solution, I have 0, comma, 5, and parentheses on both ends. All right, questions about that? Okay, let's look at another one. So sometimes they're written in this function form, and sometimes they're just given to you as an inequality. We still do it the same way. You do need one side set to 0, though. So always move your terms with the inequalities. Always move them from the right to the left, because then the inequality is easier to read. So you want your function, inequality, and then 0. So let's subtract 5x. So I will put it in the middle here. Okay. So still the same way, I want to find the zeros. When you want to find zeros of a quadratic, you want to factor if you can. If not, we have to use quadratic formula. This one does not factor, so we're going to use quadratic formula. So x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. All right, we're not graphing, we're not doing a word problem, so we need exact answers. So calculate just what's under the radical first. Okay, so square root, you should get 33. Okay, over 2. So is square root of 33, is that an imaginary number? No, so these are x-intercepts. These are zeros. And they are x-intercepts. So even though it's irrational, I still had x-intercepts. So these are the two that I have to graph. So the smaller one would be 5 minus square root of 33 over 2. And then 5 plus square root of 33 over 2. Alright, so you want to go back to the inequalities where you have the 0. So this one here. So since it's equal to, I'm going to have closed circles. And less than is above or below. Okay, below x-axis. So closed circles, and I want below. Does this parabola open up or down? Up. So and I want what's below. So this part right here. So on my number line, it's this interval. So 5 minus square root of 33 over 2. So 5 plus square root of 33 over 2. range of answers. You get an interval. So that's why you have to write these answers in interval notation. You're not done until you've written the interval.
And you want them, you would want us to like round that.
Right. Unless it says to round, or if it's a word problem, or you're graphing on a coordinate plane, then you want exact answers. Okay. Simplify if possible. So if this had been square root of, let's say, like 40, okay, you could take a 4 out so you can simplify if possible. All right, let's look at another one, another quadratic. All right, so find the zeros. Factor if possible. So it multiplies to give you positive 9 and adds to give you negative 6. Good. Negative 3 and negative 3. So my zeros are 3 and 3. So that means that has a multiplicity of 2. So on a graph, what does that mean? So there's a bounce here. Okay. Opened or closed circles? Closed. And above or below the x? So closed circle, and it's going to bounce, and it opens up or down? Up. So we want the part that's above the x-axis, which is what? Yeah. So all of this and all of this, and it's greater than or equal to, so I can count my 3. So that's everything, all real numbers, which is negative infinity to positive infinity. Let's say though that it was you wanted g of x or t of x strictly greater, so not equal to. So if that's the case, you have an open circle here. Okay, if that's the case, then your answer is everything except 3, because you can't count it because it's not equal to anymore. So remember how to skip a number, negative infinity to 3, union 3 to positive infinity. So can we see the difference between the equal to and the not equal to? Any questions about this problem?
What if it had been less than?
Okay, so if it's been less than, then there'd be no solution for either. If it's less than or equal to, it would have just been 3. Like you would have had a single element. If it was just less than, then it would have been no solution. Yes? Yeah, so we'll see another one kind of like that, but to write a single element is just this. when it's only one thing, you could even just tell me x equals 3, because that's the only thing it could possibly be. It's not even really needs to be an interval, but this is fine. We'll have to do this on a problem anyway here coming up. All right, so that's quadratics. Now let's just look at polynomials in general. So we'll do it the same way. We're going to do it the same way we do quadratics, by finding the zeros and then graphing on that number line. So when it's in factored form, it's pretty easy to find. I have a 0 at -6 and one and 1. So 1 has a multiplicity of 2. Okay. Alright, so I'm going to have closed circles, and do I want above or below? Below. Okay.
I don't know if you want to go below.
So less than is below, and then greater than is above. Okay, so with polynomials, so quadratics, it's opening up or down. The end behavior is either up, up, or down, down. Now, polynomials that are higher, you have to think a little bit more. You need the degree. So, I know I have closed circles here. But let's think about the degree. So when it's in factored form, remember you add the multiplicities. So -6 has a multiplicity of what? And 1 has a multiplicity of, so my total degree is 1 plus 2, which is 3. So my end behavior, it's odd. There's not an a value, so that's 1. So down, up, down, up. So on a graph, when it has a multiplicity of 1, does it go through or bounce? Yep, straight through. And it doesn't matter as much about the straight through or the inflection through for this. But yeah, it does go straight through. So this is through. And the multiplicity of 2 has a bounce. So we're just doing a sketch, so you don't have to put the arrows at the end, but you can. Okay. So we want the parts that are below. That would be right here. So on the number line, that's me shading here, just this interval right here. And it's equal to, right? So I also am including that point there. I have to include 1 because that's also equal to. So the equal to parts come from -6 and 1. And then the less than is this interval from -infinity to -6. So when I write that, I have -infinity up to -6 with a bracket. So that includes up to here. And then I want to include this single point, which is where I do the bracket. So remember when you have an open circle and you want to skip a point, then you have those double parentheses. If you have a point, a closed circle, and you want to include it, a then if these had been open circles, so if I wanted where it was just less than, so open circles, okay, then the only thing I would have would be this right here, and I would have a parenthesis around the -6. I would not need to include the 1 there because it's not equal to. Nothing here is less, nothing right of -6 is less than 0. Does that make sense? Okay. Let's look at another one. So we want the right side to be 0, so let's move the two terms on the right over to the left. I'm going to subtract 4x cubed, and I'll put it here between x to the 4th and x squared. And then I'm going to add 10x, so I'll put that here between x squared and 8. All right. I want to find the zeros.
Oh, and there's a minus.
I missed the 3x squared. Thank you. Okay, so find the zeros. And when it's not in factored form, you have to do a little bit more work. So if you want to find the zeros with something that's x to the 4th, then we need to do our p's over q's and synthetic division. Okay? So I'm trying to solve for when this is 0. So 8 is p and 1 is q. And since q is just 1, then the p over q's are just factors of 8. So that's 1, 2, 4, and 8. So now that I found those, now what do I do? Yep, I have to do synthetic division to see which ones work. So let's start with 1. So 1x to the 4th, negative 4x cubed, negative 3x squared, 10x, and 8. So bring down this first one to get started, multiply, and then add down the synthetic division. And does 1 work? I don't get it. All right, so try -1. Does -1 work? Yes. Okay, so I found 1. Do I have a quadratic? Here, do I have a quadratic? No. I need 3 terms. So we have to do synthetic division again. Check -1. See if there's multiplicity. So this is my new polynomial I'm using. And I'm going to check -1 again. Does -1 work again? Yes, it does. Okay, so -1 at least has multiplicity of 2. It could have multiplicity of more. But do I have a quadratic now? Yes, so I can go ahead and factor or use quadratic formula. So multiply is going to be +8 and add 3, -6. Yep, -2 and -4. So x equals 2 and 4. Okay, so I have 4 zeros. And -1, which has a multiplicity of 2. Okay, 2 and 4. Okay. So let's go look at our inequality sign. So I need to know here. Opened or closed circles? Closed. And above or below? Below. All right. So closed circles here. Okay. The degree. What's the degree of this polynomial? 4. When it's in standard form, you can tell just by looking at it what the degree is, 4. Okay, so, and the leading coefficient is 1, which is positive. So what's the end behavior? Up, up. Okay? At my zeros, -1 has a multiplicity of 2. So do I go through or bounce? Okay, what about 2? Through, and 4? Through. Okay, so up, up. And I bounce here, I go through here, and through here. I wanted below, so here. So I want less than or equal to. So I want to include -1, because that's equal to. I include 2, I include 4, because those are equal to, and the below part is here between 2 and 4. So So how would I write this? How would I write -1? Yep, just brackets around -1. And bracket 2, 4, bracket. Good. Okay. Questions about that? So if you feel confident about finding zeros and knowing what they do on the graph, then this part's not that hard. Okay, this section, these problems aren't that difficult. But if you're still just not sure how to find your zeros, you don't really remember about end behavior or their multiplicities, it's going to make this a little bit harder. You will need to do just more practice of that. That was a lot of section 3.3 and 3.4. Okay. All right. So let's do this one, and I'm going to give you time to work on this one on your own. Okay, so for your zeros, you should have gotten -1, 2, and 4. are open circles. These all have a multiplicity of 1, so you go through at each one. It's degree 3. Positive A value, so down, up. Okay. You want less than 0, so you want the parts that are below, so right here and right here. Okay, so on the number line, here and here, so 2 intervals. So I have negative infinity to negative 1, and then I have from 2 to 4. Okay? Questions about that? Okay, we'll stop there and we'll get finished up tomorrow.